a practice test on WANs and IP routing. So, question number one is, what is a preamble? Please take the time to have a think. Please pause the video if you like, and I will play the answer in about 10 seconds. So, if you want to have a long think, please pause the video. Okay, and the answer is, preamble is a bit pattern. It appears at the start of an Ethernet frame and is basically signaling, indicating that a frame is about to come. It's giving the heads up that a frame is about to come. So it's a bit pattern at the start of an Ethernet frame that signals the oncoming of a new frame. Question number two, what is the PPP and HDLC, so PPP point-to-point, HDLC, high-level data link control, equivalent of a preamble? What's the PPP and HDLC equivalent of a preamble? Please take the time to have a think. If you want to pause the video, feel free to go ahead, else I will play the answer in about 10 seconds. Okay, 5, 4, 3, 2, 1, 0, and the answer is a flag. That's what is referred to in PPP and HDLC. That's the equivalent of a preamble. It's as a flag. Okay, question number 3. Which layer in the TCP/IP model does a lease line provide a service for? Which layer in the TCP/IP model does a lease line provide a service for? Please feel free to have a think and pause the video if you like. Else I will play the answer in about 5 more seconds. Okay, and the answer is layer 1. It's layer 1. Layer 1 is the layer in the TCP/IP model which a lease line is providing a service for. Question number 4. I'm going to show you an IPv4 header. Please name the missing fields. So here we have it. We've got 3 missing fields here. Please take the time, have a think, else I will resume the answer in about 20 seconds. Okay, 3, 2, 1, 0, and the answer is, so you got your flags, you got your time to live field, and you got your header checksum. Those were the 3 missing ones. So we're starting from the top version: length, DS field, packet length, identification, flags, fragment offset, time to live, protocol, header checksum, source IP address, destination IP address. Now, question number 5, true or false? When a router makes a forwarding decision to route a packet from one network to another, it removes the layer 3 header and trailer. Is that true or false? Please have a think. Take the time to have a think. If you want to pause the video, please feel free to go ahead. Otherwise, I'll give myself about 10 more seconds. So true or false? When a router makes a forwarding decision to route a packet from one network to another, it removes the layer 3 header and trailer. Is that true or false? I'll give yourself 10 seconds. Okay, 3, 2, 1, and the answer is false. So, very, very important to know, the layer 3 header and trailer are not removed. Neither is the layer 4 header and trailer removed. It's the layer 2 and header and trailers that are removed, and that's called de-encapsulation. So you got, for example, let's say you had an IP packet that's been forwarded from router 1 to router 2. Router. Okay, well, let's say it's going from PC1. Is going, and that will go, and then the hops that it needs to take is PC1 to switch 1 to router 2 to switch 2 to PC2. Okay, so you've got there, I think, 6 nodes. Yeah, you got PC1, switch 1, router 2, switch 2, and then you've got PC2. So you got 6 nodes there, and so when the frame is being sent from PC1 to switch 1 to router 2, what happens is, so when the packet's being sent from the PC to your switch to your router, you've got de-encapsulation at layer 2. The packet is encapsulated, so you got the packet, holds the data, but the packet needs to get encapsulated. It gets attached with a layer 2 header and trailer, and this changes at every hop. It's changing because yeah, at every hop, in this process until it reaches the destination, we're going to have a new header and trailer because the layer 2 addressing is changing. The MAC addresses, the source and destination MAC address changes when it's PC1 going to switch 1. Then PC1's then the layer 2 header. Then at layer 2 we've got a source MAC address of PC1, destination MAC address of switch 1, and then when the packet gets to switch 1, then the source MAC address is switch 1, destination MAC address is router 1, and then when it gets to router 1, then the source MAC address is router 1, the destination MAC address is router 2. Every hop we're changing the layer 2 addressing. The layer 2 the source and MAC addresses change, so that's the necessitates a changing of the layer 2 header and trailer. And so this is very, very important, is that when routers make that forwarding decision to go sending a packet from one network to another, the layer 2 addressing is changing. That's why we have de-encapsulation and re-encapsulation at layer 2. Now, question number 6. In this topology, we've got 6 routers. Now, there's 3 serial links connecting these routers, as you can see, between router 2, 3, 4, and 5. And host 1 is sending a packet to host B and is traversing all these routers. How many times is the packet being re-encapsulated by a router? Please take time, have a think. I'll give yourselves about 15 seconds. If you want to pause the video, feel free to go ahead and pause the video. Okay, 3, 2, 1, 0, and the answer is 6 times. So, if you look here, we've got the packet, right? The packet sent from host 1 to router 1. Now, a router 1 source and MAC address will change when it needs for this next hop. Now, if the source MAC address was originally at layer 2, it was host 1 on source MAC address, destination MAC address of router 1. When we get to router 1, now the source MAC address is no longer host 1 and the destination MAC address is no longer router 1, so we need to change. So we de-encapsulate the packet, okay? We discard the layer 2 header and trailers because now those are irrelevant anymore. They're out of date. So those become outdated, we throw them in the trash, we create new ones, we re-encapsulate for that next hop. Source MAC address of router 1 and then destination MAC address of router 2. So that's the first encapsulation there. Second encapsulation will be here. The third encapsulation will be here. The fourth encapsulation will be here. The fifth encapsulation will be here. The sixth encapsulation, de-encapsulation are here. And then finally we reach the destination, and now the packet has reached the packet's now reached its destination. Excellent. So that's 1, 2, 3, 4, 5, and 6. 6 times we're having this process of de-encapsulation and re-encapsulation. Okay, so the first de-encapsulation, the second re-encapsulation, third de-encapsulation, re-encapsulation, the fourth de-encapsulation, re-encapsulation, the fifth de-encapsulation and re-encapsulation, the sixth de-encapsulation and re-encapsulation. Here we'll just have de-encapsulation occurring, but there's no re-encapsulation. There's no need to, because it's reached its destination. So, the question number 7, true or false? The term E-line is synonymous with a serial link. Is that true or false? I'll give yourselves about 5 more seconds. Okay, and the answer is false. So the term E-line is an Ethernet WAN link technology. It's not a synonym for serial link. There's 2 separate things. So that is an Ethernet WAN link technology, E-line. Okay, it uses So E-line is an Ethernet WAN link technology. Serial links, these have different names: private link, least serial kit, point to point. But E-line is not one of them, so it's very important to not get them too confused. Question number 8: what is the type field in an HDLC frame used for? What is the type field in an HDLC frame used for? Please have a think. We'll give ourselves about 10 seconds. 5, 4, 3, 2, 1, 0. And the answer is the type fields used to identify the layer 3 payload that is being carried inside the frame. Okay. That brings me to the end of the practice test. So thank you so much, guys, for watching. Really appreciate it. If you benefit from the video, please like, share, and subscribe. If you want to see more videos like this, please let me know. And I will see you in the next video. Thank you so much for watching. Thank you. Bye.